This is a review. This is a review for quiz 12.1 to 8.2, and that would be tomorrow, Friday, April the 8th. Okay, so problem number 1, you need to give the vertices, edges, and faces. So vertices, you have 7. It's 6 on the base and 1 at the point at the top. So this is 6 and 1 more is 7. Edges, well, you have 6 edges and then another 6 on the lateral faces. That's 12. Faces, you have 6 faces on the lateral sides and then 1 on the base. And that would be 7. So it's 7. Edges is 12. Faces is 7. And what's the name of that? Hexagonal pyramid. That is right. So it's hexagonal pyramid. And the pyramids and the prisms get their name by their bases, the name of the bases. Okay. Now for number 2, how many vertices do we have?
1.
Vertices.
2.
You were right. The first time you were right. It's only 1. It's the one at the top, yes. How about edges?
0.
0. You don't have any edges. How about faces? 1. Which is that face? The circle. Yes. And the name of that figure, it's a cone. I remember one time one student said, it's a circular pyramid, isn't it? It looks like a circular pyramid, right? But it's not a pyramid, because a pyramid you need triangles on the lateral faces. And that's the reason why it's not that. Okay, so number 3. Number 3, number of vertices, well, you have 4 on top and 4 on the bottom. That makes 8. Edges, you have 4 on top, 4 on the lateral faces, and 4 on the bases. So that is a total of 12. Yes. Faces, 4 around on the lateral faces, 1 on top, 1 on the bottom. You're right, is 6. And the name of the figure is what?
Rectangular prism.
Rectangular pyramid.
What pyramid?
Oh, that is right. It's a prism. Why is that a prism?
Because it's a square box.
It's a prism because the lateral faces are rectangles. It's a pyramid because the lateral faces are triangles. Okay, that's what makes one and the other. Got it? Great. And now, what did you put for number 4? When you fold that knit, that would be a? It's a cube.
Square prism.
It's a square prism, but the special name, it's a cube, right? And how about for number 5?
A cone.
That is a cone.
A circular pyramid.
A circular, no, it's not a pyramid. Number 6?
Pentagonal pyramid.
Pentagonal pyramid, yes.
So if it was a decagon, it would be decagonal pyramid.
Decagon, you mean decagon?
Yeah. Decagonal pyramid. Right?
Decagonal pyramid. If the base has 10 sides, yes. And octagonal, if it's an 8.
Always like kind of ends in octagonal.
Ogonal, yes. And 9 would be a what? Nonagonal, yes. Okay, so what about number 7 when you are asked to get the cross section? The cross section is like if you cut it, you open it, and you look at the inside. What shape are you going to see when you do that? It could be a square, yes. Oh, what am I putting? It's a square. Where's my eraser? It's a square. I cannot erase it, I'm sorry. Okay, so not this. It's a square. Some of you said rectangle, right? It could be a rectangle too, yes. Depends on whatever the base is, but it looks like it's a square. Number 8, it's a rectangle. Number 9, it's a circle. How can I make an ellipse out of a cone? Do you know what an ellipse is? It's a circle that is elongated. Yeah, kind of like this.
Like an oval?
Like an oval. How would I make an ellipse out of a cone? This is just a challenging question. I guess.
Oh, really wide.
Really wide cone? No. No. Uh-huh.
I feel like if you cut it from the other side.
What do you mean from the other side? Let me go ahead and draw this cone. Here's a cone. How am I going to cut it?
Or would you just cut like the whole triangle? Look at the bottom.
Well, it looks like an oval in the bottom because that's the way you draw it, okay? But it's really a circle. Okay, well, which way, Mikey? Stretch it. All you gotta do, the cross section has to be in a diagonal way.
Oh.
If you cut it in a diagonal way,
Because then
it's gonna be an elongated, yes, an ellipse. Well, you never know. When you get to pre-calculus, that's what you're gonna study in chapter 7, section 2, section
Wait,
3.
so if it's on the quiz, what am I, like oval or like?
It's an ellipse. It should be a bonus, right? Yeah.
Wait,
Okay.
is spelling gonna count?
Number 10, draw all 6 orthographic views. What you're supposed to have here, it's something like this. Do you have that? Yes? For the front, you're supposed to have 3 squares going down, and then one on the side, yes. For the right is the same thing as the front. For the bottom
It's kind of the same as the top.
is kind of the same. The only thing is that is
Oh, turn around.
turn around, yes, like that. So it's 3 squares like that. And the back,
Would it matter like what way it's facing?
yes, it does matter. The rotation, it does matter. So when you pick it up, what are you gonna see? That's what you need to ask yourself. So when you pick it up, then you look it from the bottom. So don't try to go like this because then you're gonna change the orientation. Yes, you're gonna be able to use the cubes. Yes, just in case you're one of those visual people, you'll be able to use that. Yes. Okay. So now for the back is 2 squares, and then is 1 on the top. Same thing for the left. I'm making this bigger. Okay, so now what about on the isometric drawing? You want to start with the corner. So I'm going to go ahead and start with this corner here. So drawing those 3 segments. So I'm going to start with that.
You're supposed to draw the picture.
Yes. And then that has 2 squares, and then you have 2 squares to the other side. So I'm already drawing the 2 perspective corner right there. Then you have 2 at the top, and whatever is on top we're going to be shading. And then you have to go from another corner. It's 2 going up. Oops. No lines in the middle. So I'm a little off. I didn't plan properly, but it's okay. You can just add up whatever is missing. And there you have your isometric drawing. So it's a 3-corner perspective view. Okay. And now for number 12. In number 12, it says, for each 3-dimensional figures, find the missing value with the correct number of vertices, edges, and faces. So first of all, to find the faces, as you know, Euler's formula is vertices minus edges plus faces, and that is supposed to be 2. So when I substitute the numbers, like for number 8, this one here. For that problem, when I substitute the numbers, you can the vertices is 8, the minus 12, plus the faces, and that equals to 2. Okay, so when you find the f, this is going to be 8 minus 12 is negative 4. So this is like an equation. It's basically an equation that you're looking for the missing side. So how many faces? That would be 6 faces. It's supposed to be 6. So the drawing. To do the drawing, oh, I put a 6 on the wrong spot. Okay, so for the drawing, which is this one here, it has 8 vertices, 12 edges, and 6 faces. What would be the name of that polyhedron? It's a rectangular prism because it has 8 vertices, 4 on top, 4 on the bottom. Edges, 4 on top, 4 on the lateral sides, and 4 at the bottom. So it's 12 edges. And faces, 4 around, 1 on top, 1 on the bottom. So it's 6. So let's go ahead and draw that. So you draw. And that's what you have. So it could be a rectangular prism. Could it be a cube? It could also be a cube, right? So it's a quadrilateral prism, I guess, yes. Okay. Okay, so that was this one. Okay, so now, what about for the next one, which is, you do it the same way. What was the answer for 9 and 15? The missing vertices was what? 6 is right. Yes. So it's supposed to be 6 when you set up the equation. And what was the name of that prism, of that polyhedron? What would that be? It is a triangular prism, yes. So you can draw a triangle, you can draw another triangle, and then just connect the vertices. And there you have 6 vertices, 3 and 3 is 6, 9 edges, 3 is 6, 7, 8, and 9. Faces is 5, so 3 on the lateral sides, 5 and 6 on the bases. 4 and 5 on the bases. How about the next one? 7, what, and 7? What would that be? 12 edges. And why is 12? Because you add 7 minus e plus 7 equals 2. So it's 14. When you subtract 14 to the other side, it's negative 12, and then divided by negative becomes positive 12. Now, what do you draw for that one? It's a hexagonal pyramid. That is right. So we draw the hexagon, and then we just connect them. Yes, I'm going to go ahead and do a hexagon, the hexagonal pyramid that is a little tilted like that. And there's a hexagonal pyramid. Okay, so it's 7 vertices, 6 on the bottom, 1 on the top, 7 faces, 6 around, 1 at the bottom, and 12 edges, 6 on the lateral sides and 6 on the base. So that is
for
12.
that one, you put on the calculator 7 minus 7.
The equation would be 7 minus e plus 7 equals 2.
And then from there,
You combine the 7 and the 7 becomes 14.
but so we add.
You need to combine the numbers. In this case, you add them up, yes. So when you subtract the 14 from the positive 2, it's negative 2, but then you divide by negative 1, and that gives you the positive.
Oh, so it always has to be positive.
I'm sorry, negative 12. Well, in this case, remember length of sides, measurements, all of that, it has to be positive. So if it's not positive, you made a mistake. So number of edges would be positive 12. Yes, okay, great. Now let's go ahead and go to the second page, the back side.